We're going to do another problem with trig substitution, just because I love them so much. And here we actually have a very similar form to the last problem. We have a constant plus a t squared, but we don't have the 1 plus a t squared. So whenever we want to do these trig substitutions, we want to take advantage of the identities, right? The identities always have the 1s in them because they're related to the radii of the unit circle. So we want to get rid of this 4. We can do that by factoring out the 4 right in the denominator. So we can do 1 plus t squared over 4. Right, and then this is going to become a square root of 4 times a square root of the polynomial there. So that's going to come out to be 1 over 2, 1 over the square root of 1 plus t, and then we're going to go ahead and make that 4 2 squared, just to make it look simpler. Right, and so now we know that our substitution should be that t over 2 is equal to tangent of theta, which means that dt is equal to 2 secant squared theta, d theta. And I forgot the dt here. But whenever we make the substitution, we're going to get a 1 over 2, 1 over the square root of 1 plus tangent squared theta times a 2 secant squared theta, right? And our 2's here are actually going to cancel out, so we're going to cancel out those 2's. This one is going to end up being a secant theta, right? Because the 1 plus tangent squared theta is going to be secant squared theta, and then we're going to take the square root of that, so it's going to be secant theta. So then we're going to get the integral of secant squared theta over secant theta is the integral of secant theta d theta. And as we saw in the last video, or a couple videos ago, our integral of secant theta is actually something that we know it's going to be ln of tangent of theta plus secant of theta plus c. Right, but we can actually figure out values in terms of t. Our t over 2 arctangent is equal to theta. So if we draw that out, right, we have this theta opposite or adjacent. Hypotenuse is t squared plus 4. Then our tangent of theta is obviously just going to be tangent over 2, right? That was the substitution we made earlier. But our secant theta is actually going to be, again, the hypotenuse over the adjacent because this is 1 over cosine. So we're going to have 1/2 square root of t squared plus 4 plus our constant, which is the final answer. Again, a simpler problem than the previous two. Well, only because we were able to make a good trig substitution.